Welcome back. In this segment, we're going to look at a couple more combinatorial proofs. First, let's start with a famous identity called Vandermonde's identity. Let m, n, and r be non-negative integers such that r is less than or equal to both m and n. Then Vandermonde's identity states that m plus n choose r is equal to the sum for j equals 0 up to r of m choose r minus j times n choose j. So I want you to go ahead, pause the video, and find a combinatorial proof of this identity. Then come back and check your answer with me. Okay, so let me give you my proof so that you can check or compare your proof against mine. So, let's say I'm considering the set of all students in our class, and m is the number of male students, while n is the number of female students. And let's say I want to form a single team of size r. So let me write this down then. M is the number of male students in the class. N is the number of female students in the class. So clearly m plus n is the total number of students in the class. And r is the size of the team that I want to form. So in conclusion then, the combinatorial problem or the counting problem that I just chose is what is the total number of ways I have to form a team of size r where the team members are chosen among the m plus n students in the class. So now that we've chosen the interpretation of the left-hand side of the identity, we're going to start with it. And now we have to find a different way of counting this same number. So in how many ways can I form a team of size r? Well, one way to look at it is to distinguish possible compositions of the team based on the number of female students in that team. So this number then is equal to a sum of terms, each of which corresponds to the number of ways to form the team containing a specific number of female students, starting with the number of ways to form the team with no female students in it, plus the number of ways to form the team with exactly one female student, and then exactly two female students, etc., until I have r minus one female students, that is, all the teammates are females except one, and finally, all the ways of forming a team of size r with exclusively female students in the team. So notice here that I have different ways of solving the problem, different approaches to the problem of forming a team of size r, and these approaches do not overlap since there are no team compositions in one set as well as in another one. Therefore, I'm entitled to use the sum rule for this step, and that's what I've done. Now all we need to do is to compute the number of each one of the terms in the sum. So let's look at the first term. How many ways do I have to pick r students out of the m male students in the class, since I don't want to include any female students? Well, the answer is m choose r. So that was easy. Let's look at the second one. How many ways do I have to form a team of size r containing exactly one female student? Well, that I can break down into two sub-steps. The first step is to choose a female student to include in the team. How many ways do I have to do that? And choose one, since n is the number of female students. And for every choice of a female student then, I still have to choose r minus one male students. And the number of ways to do that is m choose r minus 1. Notice here I'm using the product rule, since to achieve the task of forming a team of size r, I first need to perform the first step, choosing the female students, and then the second step, which is choosing the r minus 1 male students. And since these two subtasks are independent, I can just use the product rule. Of course, a similar reasoning is going to apply to all of the other cases. So, for example, to form a team with exactly two female students, I first choose two female students out of a possible n female students. And then for each choice of these 2 female students, I must still choose r minus 2 male students out of a pool of m such students. So the same goes on all the way to this step. For r minus 1 female, I have n choices, so the first factor will be n choose r minus 1 times the number of ways to choose one more student out of the male population. And finally, the total number of ways to make up a team of R student is the number of R combinations, that is the number of subsets of size R taken from the total population of female students, which has size n. Now notice that in the statement of the identity we want to prove every term is a product of 2 binomial coefficients here. So I'm going to add a coefficient here that's equal to 1, and that's going to be n choose 0. Then I'm going to leave these terms unchanged, and here I'm also going to have to add a term that's equal to 1. In this case it's going to be m choose 0. And now all we have left to do is to tidy up this complex expression. So you can look at a pattern here. You always have n and m at the top, so that's constant. Here we have 0, 1, 2, all the way up to r minus 1 and then r, so this will be the j in our summation. And on the right side, on the bottom, we'll have r minus 1, r minus 2, dot, 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 r minus 1, and r minus r. So we're going to have an r minus j at the bottom of the right-hand side. Notice this is almost equal to the identity we want to prove, except we have to swap the 2 terms in the product. Of course, that doesn't change the results. So let's do that right away. And this then concludes our combinatorial proof of this identity.